to provide a brief introduction of the speaker, Dr. Ketan Rancer. Over to you, Anita, ma'am.
Myself, P. Anita, Associate Professor, Department of Pharmaceutics, ANCP. It's my privilege and honor to introduce today's guest speaker, Dr. Ketan M. Rancer. Sir is currently working as Associate Professor in LM College of Pharmacy, Ahmedabad, Gujarat. Sir has cumulative experience of more than 16 years in teaching, training, and research in pharmaceutical science field, with 1 year of industrial experience at Ranbaxy Research Labs, Gargan. He is an accomplished and dedicated teacher and trainer with a background that reflects the ability to engage and educate students or staff in the effective utilization of knowledge to facilitate successful application from it. He employs teaching competencies to share new concepts in an interesting and effective way. He has over 10 years of experience in formulation development with the development of novel drug delivery systems as a PhD scholar and also as research guide. He has published 33 research publications in international and national journals, which includes publication in high repute journals like International Journal of Pharmaceutics, Journal of Control Release, ACS Omega, etc. He has been coordinator for DST-PIST project at MPC and played instrumental role in procuring research grant of rupees 60 lakhs from DST. He has been working as co-investigator on project of developing therapeutic lens, and thereby he obtained 8 projects from Leo Lens Tech USA of worth 60 lakhs, more than 60 lakhs as co-investigator. He has written 4 book chapters and 1 book, which includes a book chapter in Remington's Pharmaceutical Sciences. He also has expertise in design of experiment with sufficient knowledge in EndNote and SPSS statistics package software. Recently, as co-investigator, Sir has received rupees 46 lakhs grant from Gujarat Council on Science and Technology. He had been active member for accomplishing NAC accreditation at UTU. He has trained industry personnel and on DOE in association with Systech Technocraft Services Private Limited. He has delivered more than 50 guest lectures at national and international conferences and trained thousands of budding pharmacists in area of pharmaceutical sciences. He has guided 1 PhD student and 38 MPharm students for their research and dissertations. And his area of research interest is ocular drug delivery, drug eluting contact lens, applications of nanotechnology in drug delivery systems, and design of experiment. With this brief introduction, I wholeheartedly welcome Dr. Ketan M. Rancer to deliver his talk. Welcome, sir. Over to you.
Very good morning to all of you. Thank you very much, madam, for your kind introduction. Am I audible, sir?
Yes, sir.
Yes, sir. Yes, sir.
Yeah. So, Honorable Principal Swarnalata, madam, organizers Reddy, sir, also Dr. Surya Prakash Reddy, sir, and other faculty members, as well as participants. Very good morning to all of you. It's a matter of honor, it's a matter of privilege, as well as pleasure for me to learn something via a channel of resource person in this AICTE sponsored STTP. So before I begin, let me share my screen to all of you. Am I audible clearly, madam?
Yes, sir. Yes, sir.
Yeah. Hello.
Yes, sir. Yes, sir.
Am I audible, sir, now?
Audible, sir. Audible, sir.
Okay,
But the screen is not visible, sir.
Yes. I am just sharing my screen.
Okay, sir. Okay, sir.
Is it visible now, sir?
Yes, sir. Yes, sir. Make it slideshow, sir.
Yes, sir, sure.
Yes, sir. Yes, sir. Perfectly all right, sir. It's now.
Fine now?
Yes, sir. Perfectly all right, sir.
Okay. So once again, a very good morning to all of you, and welcome to this session 3. Welcome to the day 3, session 1 in AICT sponsored short-term training program organized by Annamacharya College of Pharmacy, Rajampet, Andhra Pradesh. At the outset, once again, I am thankful to the principals, Swarnadatta Madam, Surya Prakash Reddy Sir, as well as Dhyaneswar Reddy Sir, for giving me an opportunity to share something what me and my students have done at my workplace. So the topic on which we would be learning and going through is application of design of experiments, a statistical and computational tool, a case for development of therapeutic lens for ocular drug delivery. Now, before we go ahead, let me have some glimpses of the basics of design of experiment. Are my slides changing, sir?
Yes, sir. Yes, sir.
Okay, fine. So all of us are engaged in experimentations. So we are there as a scientist, we are there as a investigators for performing different variety of experiments in all fields of inquiry, whether it is social science, whether it is pharmaceutical science, physical science, biological science, engineering science, and so on. This we are doing with a purpose to study, to investigate a process, or to develop a product, or to develop a system, whereby we run an experiment, which would be a kind of a test. For example, we want to investigate the effect of consuming a salty water on the blood pressure of animals or on the blood pressure of human being. We want to investigate the effect of variety of diets on cholesterol level of some individuals or on some animals. I want to investigate what would be the effect of polymer concentration onto a release of a drug from a oral controlled drug delivery system. So we are involving not only in study of various processes or a system, but we are also involved in determining, in studying the associationship or the relationship between different factors, whereby we do an experiment with deliberate changes into it. Such deliberate changes are like to the input variables of a process or a system. I change the concentration of a catalyst and then I check the percentage yield of a synthesized chemical compound. I change the temperature at which my reaction is being carried out and then I determine what is the impurity level or what is the percentage yield of a chemical compound which is being synthesized. I change the pressure at which the reaction is being carried out and then I determine what is the yield of a chemical compound being synthesized. So deliberately the input variables like temperature, the pressure, the catalyst concentration, the polymer concentration, the salty water or the normal water, the diet rich in fat, normal diet rich in protein, and then we go on determining its various responses, cholesterol level, the blood pressure level, the percentage release after 8 hours or 12 hours, or maybe what is the percentage yield of a chemical compound being synthesized, what is the impurity level over there. Now, these are some of the output responses. Now, over here, if we could develop some association or a relationship between the input variables and the response mathematically, statistically, then we can reach to our desired response, we can reach to our optimum response, whereby somewhere we would be writing, we would be desiring to have our maximum yield, somewhere we would be desiring to have minimum impurity level. So we want our product as pure as possible. Somewhere we are here to establish or to confirm the hypothesis that the salty water increases the blood pressure and so on. So these different types of experimentation plays an important role in commercialization of various technologies, in realizing the product and its properties, okay, which may be through designing of a new product, which may be through a formulation of a transdermal formulation of a nano suspension, which may be through a manufacturing process development, whereby we want to develop such a we want to validate a blending process, thereby we can achieve a content uniformity of a potent drug whose dose is just 0.25 milligram and so on. We would be desiring to improve the process as well. Right now the process is taking around 1 hour. We want to bring it down to 30 minutes and so on. At the end, whether you want to realize a product develop, whether you want to improve a process, whether you want to associate or relate or correlate the different variables, at the end we want to develop a robust process, and that is being a process which is affected minimally by external sources of variability. We often come across to a situation, not often, we obviously come across to a situation whereby we find that there are a lot of variations into the product, into the process. If I take a particular analyte solution, a drug solution, and fill it into a cuvette and determine or measure its absorbance at a particular wavelength, then I would be able to know that it would show me, for example, 0.243 absorbance. Once again, I remove the cuvette and then again I put it into the UV double beam UV spectrophotometer. It would show me, for example, 0.26 or 0.251. Now the same solution is showing different absorbance. So there are variations into the instrument. There are variations into from analyst to analyst. There are variations into the various apparatus that we have been taking. So variation is inherent in most of the product and processes which we come across. Now, how these variations can be minimized, how these variations can be estimated using concepts and fundamentals of the statistics. Let me give you with a very simple example from something from a pharmaceutical engineering background, whereby a metallurgical engineer is interested in studying the effect of two different hardening processes. We are going to develop a particular metal, and that particular metal has to be hardened via certain processes. Now there are two different medium into which this particular metal can be, this particular alloy can be hardened. One oil and one is salt water. So the particular alloy will get quenched with the oil and will harden. A particular alloy, aluminum alloy, will get quenched with salt water and will get hardened. So there are two variables which I am studying, and one of the output over here response is the hardness or the strength of my alloy. Okay, so objective of me or objective of that particular engineer is to determine which quenching medium, which quenching solution produces maximum hardness for this particular alloy out of these two given medium what I am going to study. Is it fine? Now, if I consider this simple experiment, a number of important questions that comes to my mind. Okay, can you please help me? If you are there as an experimenter, if you are there as a pharmaceutical engineer or a formulation scientist, what all questions comes to your mind if you have been asked to design an experiment with such particular situation? Please, I would love to interact with you all via chat box, and I hope if the organizers allow them to unmute themselves, and we can just talk on this given strategy of experimentation. May I have some answers into the chat box? I hope you are very much clear with an experiment whereby an engineer is trying to develop an alloy metal which is hard enough and he has a process whereby a metal can be hardened, an alloy can be hardened by quenching in two different media. One of the media he is using is certain kind of oil, and one of the another media he is using is salt water. Now, what all question comes to you if you have been asked to design an experiment whereby you are to determine which quenching medium would produce the maximum hardness for this particular alloy? Yes, please, into the chat box. Anyone? Hello. Am I audible to everyone?
Yes, sir.
Yes. So can we have some answers into the chat box, how someone would be able to design this particular experiment, so that gradually I'll be taking on you to the different concepts associated with design of experiment and how we can use it effectively to get to our desired responses. Okay, will not take so much of time and will, okay, in quenching, we have to look into the process of quenching and material used for the same. Yes, the process of quenching would be very much similar whether you do quenching using a medium oil or using a medium salt water. So that has been controlled. So Dr. Sucharita Madam has rightly said that the process of quenching has to be also taken into consideration, because that may have an impact onto the hardening of an alloy. So obviously, there is another third variable, the way in which quenching would be taken, the way in which quenching would be done with these medium should be taken into consideration. So which would always be a control. So if we are doing quenching via X method with oil, we would be also doing quenching via X method with salt water also. Okay, and material used. Okay, I hope I'm very much sure whereby Sucharita Madam is also trying to say to us that there can be some other materials which would also be used for quenching. Yes. So apart from these two, like oil and salt water, what are other materials that can be used for hardening of this alloy via quenching process? Have we taken them into consideration? Have we studied them as a preliminary experiment? Have we got some literature review with this material? Very fine. Thank you, madam, for your active engagement. So what rightly being said by madam, are only these two solutions being the quenching media of potential interest? Have we studied that? Are there any other factors that are going to impact on hardness of the alloy which I am investigating? Are they controlled in this experiment or not? For example, if I am doing a quenching with oil at a room temperature and with salt water at 35 degrees Celsius or at a 40 degrees Celsius, then there would be a variation into my response of the hardening. So there are other factors like process of quenching itself. Are we able to control it or not? How many samples or coupons of alloy should be tested in each quenching solution? If I have taken an oil, I am using 3 different samples of aluminum alloy. That is, I am doing this experiment where n is equal to 3 or n is equal to 6 with alloy, and n is equal to 3 or n is equal to 6 with salt water or not. That we are supposed to take into consideration whenever we are doing an experiment. Now, how these samples, how these coupons are assigned to a quenching solution. For example, sample 1 with oil, sample 2 with salt water, sample 3 with oil, sample 4 with salt water, and so on. I am trying to say over here into the last point on my slide, as well as second last point onto the slide, is about replication, is about randomization. Am I able to do enough randomization of the treatment? The treatment over here is quenching with oil. The treatment over here is treatment quenching with the salt water. Am I doing enough number of replications and repetition? Okay. Am I controlling my other variables? So controlling replication, randomization, okay, preliminary study to know what are other factors, other variables that are affecting. See, all these are some of the basic fundamentals, basic principles of experimentation. If you do not consider these basic principles and these basic fundamentals, whatever conclusions, whatever information that yield out from this experiment would not be reproducible, would not be so much valid, and would not be acceptable by the global scientific community. Please mind it. So we as a scientist, we as a teachers, we as a investigators are supposed to perform, are supposed to demonstrate and conduct any experiment which satisfies the basic criteria of strategy of experimentation. Okay, so I hope I'm making a sense of it. What method of data analysis I will be using? I'll be getting the results from quenching by oil. I'll be getting the results from quenching by salt water. Okay, so there would be mean of the hardness value from oil, mean value from the hardness value of the salt water quenching. How I am going to compare? How I am going to do hypothesis testing? Am I going to use a student t-test? Am I going to analyze it via ANOVA? Am I going to use it f-test? And so on. So what are the different methods of data analysis? Am I going to do a correlation study as the concentration of salt water increases, the hardness increases or not? Am I going to develop certain kind of a regression model, a mathematical model between the input variables and the response? So what all different sorts of method of data analysis I would be using? This all something we call it as a strategy of a experimentation. What difference in average observed hardness between two quenching media will be considered important? How much? For example, with oil, I get a hardness of the material with 5. With salt water, I got a hardness of a material to 5.2. Okay, will I consider this as a significant improvement upon changing the quenching media, or we say that salt water is something a better medium to get the hardness of my alloy? So you need to decide all this as a strategy. If you do not decide, then something, the results that will be obtained will not be considered as a valid, will not be as reproducible as it could be in a well-designed experiment. So in a well-designed experiment, result and conclusions that can be drawn from the experiment will depend upon to a large extent into the manner in which how the data were being collected. If the data were being collected are not randomly being collected, if the data were collected in an uncontrolled manner, then also those experiments would be considered as a failed experiment. So coming to the designed experimentation, which we say that it is something, excuse me, arrangement of experimental runs in design space that we define it into a coded variables. I will take on to a specific example whereby we have tried to develop a therapeutic lens or a contact lens, and how this design of experiment has enabled us, has assisted us to get to the desired response value for my product, which we call it as a therapeutic lens. So we are going to investigate into a very defined area with a very firm objective. Now, once I say a very defined area, this particular area is defined by the labels of my variables. To illustrate you, when I say a label of my variable, so if I'm going to use my polymers from 5% to 15%, now this is a particular area into which I'll be running my experiment. If I am going to compress my tablets minimum at 200 millipascal and maximum at 400 millipascal of compression pressure, then this is my defined area into which I would be working to produce a tablet with a fragility of less than 0.1%, with a hardness of 5 to 7, with a disintegration time of less than 10 minutes. So that is a firm object. Okay. So I am going to investigate into a defined area with a firm objective of so and so friability, so and so hardness, with so and so decrease in blood pressure, XYZ. Okay. Using appropriate tools whereby I have my certain own methodologies of doing in vivo studies, doing certain in vitro characterization, and drawing conclusions which are justified by the empirical data, by the experimental data that I would be obtaining via my experiment. So experimental design takes into consideration, it satisfies all the principles of comparison and control. For example, if I would say Dr. Ketan is taller compared to Dr. Chirag Patel. So over here, Dr. Chirag has been considered as a control. So how much my height varies in relation to Dr. Chirag. Okay, how much my blood pressure varies is something related to a reference value of 80 mm Hg to a 120 mm Hg systolic and diastolic blood pressure, and then thereby I am being labeled as hypotensive or a hypertensive. So in whatever different experiments we perform, there has to be something like comparison, there has to be something like control. Then we have replication, which is being studied to estimate the error, which is being studied for estimating the inherent noise into our system, inherent noise into process or a product. Randomization is being done to avoid the biases. Randomization is done to have an equal choices and to have an equal distribution over the entire treatment. Stratification and blocking has been also done to have an idea about any potential variation that exists into our system or a process. For example, if I have that when I do an experiment, okay, and there are certain responses. And when Surya Prakash sir does an experiment, there are certain responses. Now we find that there is a variation from analyst to analyst or from a scientist to scientist. So why can't we have certain experimental runs done by me into a one block and certain experiment done by Surya Prakash sir into another block? I will get mean of the responses from my experiment. I will get the mean from the Surya Prakash sir experiment, and then I will compare them. Now, if there are no significant differences being found with the response of my experiment with the response of Surya Prakash sir, then obviously there are no variations from analyst to analyst. So we can have blocking. Block 1 for analyst Dr. Ketan, block 2 with the analyst, with the scientist Dr. Surya Prakash sir. So such stratification, such blocking can be done. We often find that we have a variation in gender. So we can have an entire block or a strata of male rats, entire strata or a block of a female rats, and then you find out the mean between them. If you find that there are similarities, then there is no need to worry that a gender can be a potential source of a variation. So these 4 basic principles are being considered whenever you take into consideration design of experiment. Now, how should we proceed for developing a product? How should we process for developing a process via application of DOE? The first thing is that we are supposed to define the objective of study, and then we should plan the experiment. At the beginning, we should say that where we want to go. It is being said in QBD concept also, begin with an end into the mind. Where you want to go, first you decide it, and then you start planning the experiment. Like I would decide that I want to produce an alloy which is so hard enough. I want to develop a orodispersible tablet which should be dispersible within 30 seconds in my salivary fluid, which would be even less than 1 ml. At the same time, the same orodispersible tablet should pass under my friability test, that is, the friability should be less than 1%. At the same time, it should withstand the mechanical abrasion, mechanical shock, which it is getting exposed during manufacturing, during packaging, during administration, and during usage. So it should have a sufficient hardness of 3 to 5. Now I have these many objectives, and where now I should start planning my experiment. So can someone tell me, if someone please bear with me with taking an example from pharmaceutics more specifically. So can someone tell me what all factors, variables that will affect my these objectives or my these responses into the chat box to get a particular hardness, to get a particular friability, to get a disintegration, to get a pleasant taste? What are all those variables that will be impacting these responses? Yes, please. Anyone in the chat box? Okay, I'll just wait for a few seconds and then I'll proceed. Okay, so to my basic expertise into the formulation development of a tablet, I would say compression pressure at which the tablet would be compressed. I would say the amount of super disintegrant or disintegrant that I would be using. I would say the amount of the flavoring agent and the sweetening agent that I would be using to prepare that particular oros dispersible tablet. Are some of the input variables that would be affecting friability, hardness, its taste, and so on, its disintegration time, and so on. So I have n number of the factors, whether I'm compressing my tablet onto my 8 mm punch and die. Am I compressing the tablet onto 10 mm die and punches? What is the total weight of the tablet? What is the diluent that I am using? I am going to use calcium diphosphate as a diluent. I am going to use MCC as a diluent. So there are n number of factors that will be impacting my process or a program. I have to screen them out. Okay, some significant factors that would be affecting onto my objectives. Out of those many factors, I will screen it out to 2 to 3 important factors. Maximum up to 4 factors. We are discussing about step 2 onto my slide. Then with these 3 to 4 factors, for example, I come down that amount of super disintegrant, the compression pressure, and the third one is amount of the sweetening agent or a flavoring agent. Now these 3 factors, I will be studying what is the interaction between these 2 factors. So that is factor influence study. What happens to a super disintegrant when it is compressed at a very high compression pressure? What happens to a response that has to be observed by a super disintegrant when it is being compressed at a very low compression pressure? Is there any interaction between these factors? If I am using, for example, saccharin as my sweetening agent, will it be deformed under high compression pressure and the taste obtained would be not so sweet? It would be slightly bitter. Okay. So there can be an interaction between these factors. I have to study the factor influence study. Now from the factors influence study, then I go on to a response surface methodology where my entire response of disintegration time, the hardness, the friability, the taste of my tablet, okay, has to be surfaced into a 3-dimensional diagram. So whereby each my factor has to be studied at minimum 3 levels. Okay, it can be up to, they can be studied at 5 levels also. So when I say levels, for example, my design space was from 200 millipascal pressure to 400 millipascal. So I would be studying at 200 millipascal pressure, 250 millipascal pressure, 300 millipascal, 350, and 400, and so on. So I would be going into, for example, central composite design, box Banken design, optimal design. These are some of the response surface methodology experimental design. And then I'll go into the lab. I will formulate my oro dispersible tablet. I will evaluate and characterize with its release, with its disintegration time, friability, hardness, assay, and so on. And then with certain softwares like Design Expert or Minitab or maybe JMP, there are many available into the market, which would aid you with modeling of your response to reach to an optimum point, that is step 5. So computer aided modeling and search for an optimum. So my optimum point in this example, what we are discussing is we want disintegration time as minimum as possible, hardness as maximum as possible, friability as minimum as possible, and taste should be pleasant. Okay, then I need to validate my entire methodology, and then I go again for scale up and then to the entire floor space workshop production into my plant. So this is how the different steps of DO methodology goes on. Okay, so first is where we want to go. Recognize the problem, identify the problem and state the problem. And then you select your response variables. My response was disintegration time. So my variable was amount of super disintegrant. My response was friability. So I selected a variable, for example, compression pressure, and so on. Then you decide its levels, its ranges, 200 millipascal to 400 millipascal, 5% to 10% disintegrant, and so on. Then you choose your experimental designs. I will start with screening design, then I will do with factorial influence design via 2-level full factorial design. And then I will take some of the center point batches and come down to a central composite design or 3-level full factorial design to reach to the optimum point, that is statistical analysis. So performing the experiment, statistical analysis of the data, conclusions, and recommendation. So this stepwise how we go for a DOE methodology. Something can be shown with a flow chart, the entire DO methodology, what you can see onto my current slide. Okay. So via screening, we have some known factors, some unknown factors that would be screened out into vital few 3 to 4 factors. Then we study their interactions. Then we study them with few center point batches to know whether there is curvature or not. Curvature means when I increase the compression pressure, the hardness of my tablet increases. But again, when I increase the compression pressure, the hardness of my tablet decreases. So there is something like a curve. There is something like non-linear correlation between my input variables and the response what I am studying. So if there is a curvature, you go for central composite design, box Benton design, optimal design, 3-level full factorial design, and then you reach to an optimum point, then you validate your design. So this is something how our DOE methodology takes into consideration. Hope we are going well, whereby in around 30 to 40 minutes, we have covered a very basics of the DOE, and I am very much sure some of the giant experts have taken the lecture before me, and you are all well aware with the basic fundamentals of DOE. Now we will talk in next 45 minutes to 50 minutes regarding the case study which I have undertaken during my research with my students. Excuse me. Am I going well? Am I audible well?
Yes, sir.
Okay. So we have something, for example, factors. We have something like process, and we have something like responses. And then with the help of the responses, we are trying to develop some empirical models into the form of polynomial equations, which would be again analyzed by ANOVA as a hypothesis testing. We will plot contour line plot, and then we will reach to the optimization. So there is something like design of experiment. Through design of experiment, we decided our objectives. Through objective and responses, we decided our factors and labels. So that makes an entire region of operability in which we would be operating our experiment. And then in this range of operability, region of operability, we have our region of interest. We have our region of desirability. We have our region of an optimum point. Where is the sweet spot? Where is the desirability? Okay. So we will go through it one by one. Now, what we have been doing traditionally is something we call it as, let's see what happens when we change this variable. Let's see if I move this knob from this place to another place, what happens onto my response. Let's see what happens if I add one more ingredient into it. Let's see if I do not add this ingredient into it. So the way we have been doing is something we call it as, I think I'm very much sure has been covered into the previous lectures on day 1 and day 2. One variable at a time, one factor at a time. We call it as OVET or OFFET approach. Okay, traditional experimentation. So when we have been doing traditional experimentation, excuse me. We are not able to understand the interaction between the factors, we are not able to reach out to an optimum point. Plus, we have to carry out many experimental runs. So the best utilization of time and resources with minimum efforts and maximum information can be done via a design experimentation. So this is something what we can have. Controllable factors X, there can be some factors which would be inherent noise factors, and there can be a response. So we have been plotting a Lambert-Beer plot regularly at our routine practice, irrespective of our specialization, whether pharmaceutics or pharmacognosy. Okay, where we know absorbance is a function of a concentration of an analyte. Okay, so Y is a function of a X. So same way, my disintegration time Y is obviously going to be a function of compression pressure, a function of an amount of super disintegration. Hardness is also going to be a function of compression pressure as well as the amount of the super disintegrant that I am going to use. So can we establish some kind of a mathematical relationship via polynomial equation or not via design experiment? Now here is an article what we have published into a high repute journal with adequate impact factor of journal citation report, Thomson Reuters impact factor, design and optimization of novel implantation technology in contact lenses, okay, in vitro and in vivo characterization into active material. We have tried to design and optimize the contact lenses for treatment of a dry eye syndrome, and we have done its in vitro characterization and we have done its in vivo evaluation as well. So here we begin with a case study whereby we have tried to develop a product, what we call as a therapeutic lens. Okay, how this methodology was effectively applied and got award with a MPharm and PhD degree, and also got published, and we also could receive certain research grant from the government agencies. Okay, so let me illustrate with a case study of development of a therapeutic lens. Now, obviously, we know we have been suffering from short-sightedness and far-sightedness, myopia and other, and thereby be treated by wearing lenses, be treated by wearing the specs, as right now I have put on my glasses. Okay, now these are the glasses which I am using it to have a distant vision. Now, instead of the glasses, I can use the lenses. Now, when I incorporate a therapeutic drug, active pharmaceutical ingredient into my lenses, and it exhibits its own pharmacological action, for example, it would be killing the microorganism, or it would be inhibiting the growth of microorganisms. So it would be an antibacterial, antimicrobial agent incorporated into my lens. So it would be a therapeutic lens which has an antimicrobial property. If I would be incorporating, for example, a certain comfort enhancing agent like hyaluronic acid or carbopol or HPMC, so it would be treating dry eye syndrome and so on. If I would be incorporating cyclosporine, it would be treating certain kind of infections into my eye. If I would be incorporating timolol maleate, which is used in treatment of a rise in intraocular pressure, that is glaucoma, so my lens is now therapeutic lens. Okay, but when you incorporate a drug into a contact, see, this idea has been conceived from the cosmetic point of view. We find many male and female models into entertainment industry with blue eyes, with violet eyes, or with some grayish eyes, and they have put on some lenses to beautify their faces. Okay, someone wants to have eyes like Aishwarya Rai, so he or she might not have those eyes, but what she can do is that they can use certain lenses, just a cosmetic lenses, to have that particular color eye. So when a dye can be impregnated, incorporated into a cosmetic lens, why can't we incorporate a drug to treat various eye diseases and eye disorders? And that particular lens, now we call it as a therapeutic lens. So we know most of the ophthalmic drugs, this is the statement of problem, how where we want to go and what are different our objectives. Most of the ophthalmic drugs are delivered through eye drops, and we know these eye drops have a very limited ocular bioavailability. We have many literature which says that you have something less than 5% ocular bioavailability being observed. So short residence time, only 1 to 5% of the drug reaches to the target tissue, and I think no drug reaches to the posterior segment of your ocular cavity when you deliver a drug via eye drop or via suspension. You require frequent instillation at a high dosage. आपको 2%, 3% drug के solutions को instill करना पड़ता है, and which lead to a patient non-compliant. So what alternative options we have? We have novel drug delivery systems whereby you instill liposomes, you instill nanoparticles, you instill, for example, microparticles, okay, to increase the ocular drug bioavailability, to minimize the systemic drug exposure, to improve the patient adherence for better clinical outcome, okay. But apart from all those, we have into a form of like something you call it as ocular inserts, something you call it as contact lenses can be there as an alternative. So as I said, to decide upon my factors, to decide upon my labels, to decide upon substantiation or evidence with my product to be developed, I started with my literature review. So I found that sustained release of dexamethasone can be obtained from silicone hydrogel contact lenses. Molecular imprinting technology was very well studied for transport of drug through hydrogel contact lenses. Okay. Surfactant were being used to increase the drug loading, okay, which reduces the percentage release to have the sustained release via drug surfactant hydrogel lenses. There is one method in which we can incorporate the drug into the lens, what we call it as a soaking method, but it has its own limitations whereby drug release is not sustained. So that also we got a particular literature. You can develop the contact lenses using HEMA sheets, hydroxyethyl methacrylate, which is being polymerized. You can incorporate the drug into not only HEMA but into a methyl acrylate sheets as well. So based onto the different literature review, we came to know that researchers have achieved the controlled drug delivery rate using therapeutic lens, and whereby they have incorporated the drug by making its nanoparticles, by making its micelle, by making its microemulsion, by use of vitamin E, and so on. Now, these technologies have showed sustained drug delivery, but it has severely affected the physical and optical properties of the lens. Okay. Now, if someone, if any one of you have been putting the lens, okay, would obviously know that we find some itching into our eyes. Okay, and when you incorporate a drug into the lens, obviously its vision will be affected. The lens would become bit translucent. It would become maybe opaque in nature as well. Then the entire purpose would be lost, because हमने जो lens पहने हैं, what we have put on. Obviously, it should give vision to the patient when he is putting it those lenses. Plus, its physical properties, its flexibility, its elasticity, its hardness should not be compromised. Plus, oxygen permeability as well as ion permeability across the lens should also be not compromised. If these are compromised, then we will find discomfort to the patients, and patient may find that he would be getting discomfort and he would discontinue the use. Okay. So these are some of the problems which are associated when you incorporate a drug into the lens. Dry eye syndrome, okay, which is widely affected to more than 50 million people. Okay, it affects the quality of patients' life. It is very unfortunate that in this tough times, in this pandemic time, we are working online via ICT tools. Okay, most of the time we are spending in front of the mobile or in front of the computer, and we are very much prone. We are one of the very potential population suffering for dry eye syndrome. We are driving, okay, we get lights against us, we are watching television, okay. So dry eye is significantly affecting the quality of the patient's life. Treatment for dry eye are re-wetting solutions into form of HPMC, into form of carbopol, into form of hyaluronic acid, what we call it as lubricant, comfort agent. You have artificial tears, which increases the viscosity of your lacrimal fluid, and artificial tear, which slows down your tear drainage and increases the moisture on your ocular surfaces. Eye drops are there, but they are inconvenient. They have low bioavailability. They have short ocular residence time, frequent installation, and patient non-compliance. So that is my statement of problem, where I had begun to find out the solution for it. So we are trying to develop something what call it as extended release hyaluronic acid implant hydrogel contact lenses to improve the patient adherence, to have a better clinical outcome. We thought of implementing a 3:2 full factorial design. So upon screening, upon preliminary studies, upon effective literature review, what I had shown you onto my previous slides, okay, we could screen out toward 2 significant vital factors that are affecting my physical and optical properties of the lens. So my aim was to achieve minimum hyaluronic acid leaching during sterilization of the implant lenses. Now we all know all the ophthalmic preparations, all the ophthalmic products are sterile in nature. I have to sterilize my lenses as well. Now we know exposing a particular product for sterilization is a harsh condition. Whatever drug I have incorporated into my lens will be leached out during the autoclaving, will be leached out during the exposure to radiation if I am going to sterilize it via radiation sterilization, via moisture sterilization like autoclaving. So I want to incorporate the drug in such a way that no hyaluronic acid is my comfort enhancing agent, should leach out during the sterilization. Maximum sustained release, control release of my hyaluronic acid by tailoring 2 important factors. That is, one of them is a cross-linking agent, EGDMA, and one of them is a thickness of my entire therapeutic lens. Okay. EGDMA is a cross-linking agent because I am going to do a in situ polymerization between 2 polymers, between 2 monomers, and this is being facilitated by using cross-linking agent. Okay, so here we begin. These are the materials that we have used into our study. This is the composition of my placebo lens. I have used hydroxyethyl methacrylate, methacrylic acid, and one of the factor that is ethylene glycol dimethacrylate, which is a cross-linking agent. So HEMA and MA, these are monomers. These would be in situ polymerized when I expose it to a UV light, okay, and when I use a particular cross-linking agent. So higher the cross-linking agent, higher will be the matrix of polymerization between HEMA and MA will be formed. Higher the drug will be entrapped, and higher the drug will be entrapped, I will get more sustained release from it. Less amount of a drug will be leached out when it will be exposed to a sterilization. Okay, so I have selected the factors in a right way. Okay, so that it is affecting my response. Another very important variable that I have selected is the thickness of my lens material, the entire lens, because obviously as the higher would be the thickness, the lesser would be the permeability. If lesser is the permeability, it is going to cause the discomfort to my eyes. But higher the thickness, it is going to give me the sustained release as well as the controlled release. So based on these certain hypotheses, we began to develop our therapeutic lenses. So this is the entire matrix of 3:2 full factorial design. Concentration of a cross-linking agent was being done at 3 levels, 0.5%, 1%, and 1.5%. And the thickness of the implant was 40 micrometer, 60 micrometer, and 80 micrometer. Based on my objectives, my responses which were studied are leaching after sterilization, time required to release 50% of the drug, and effective ion diffusivity. That is being studied to have a comfort idea how the ion permeates, how the oxygen permeates across the lens. Okay, so preliminary experimentation has shown that if I use less than 0.5% of my cross-linking agent, whatever lens I would be able to design would be with a poor mechanical property. If I use more than 1.5% of my cross-linking agent, the lens I obtain is a brittle. So my design space is from 0.5 to 1.5%. Same way with the thickness, if it is of very low thickness, less than 40 micrometer, I won't be able to incorporate the drug into it. If it is more than 80 micrometer, I get very discomfort. Jitna lens thick hota hai, it creates very much discomfort in wearing or in putting up those lenses. So we decided to keep it into the 2 concentration. First, we tried to incorporate the drug via soaking method. This is very simple. You take hyaluronic acid solution into a beaker. You take your lens being prepared between the 2 slides, what we use it in pharmacognosy practical. Okay, you add all these solutions together, prepare the solution into a beaker. Okay, put a drop of this solution onto your glass slide. One of the glass slide, spread it with the help of the another glass slide, expose it to a UV chamber. Okay, and then you will find after some time you will get a thin film into the form of a sheets. Okay, what we call it as a p-HEMA sheets. Okay, hydroxyethyl methacryl sheets. Now I take these sheets, dip it into the hyaluronic acid solution. So these sheets will now absorb the hyaluronic acid solution from it, which we call it as a hyaluronic acid leaden contact lens prepared by the soaking method. The concentration of hyaluronic acid what we took for soaking was 0.75%. Okay, now this is something what we have tried to do it via full factorial design. Batch number 1, batch number 2, 3, 4, 5, 6, 7, 8, and 9. Batch number 5, what you see where both the factors are being studied at its central level. So I am going to study 2 independent variables at its 3 different levels. As you can see, all of them into a complete level or transform level are being said as -1, 0, and +1. Am I going well? Ready, sir?
Yes, sir.
Am
Absolutely
I
fine.
audible as well? Okay, fine. I would be more than happy to answer your queries. You can just put on your questions and queries into the chat box. Now, this is my entire design matrix, the way in which all 9 batches have been developed. This is a schematic diagram in which how we have tried to develop this entire lens. As I said you, this is very much possible at your routine resource what we have in our undergraduate laboratory also. And I'm very much sure the organizers college is accredited with A grade by NAC as well as accredited by NBA. Okay, so obviously it would be so much resourceful, and we have lot many resources to carry out a meaningful research. You have 2 glass slides into which now what happens is that we try to have develop a ring of our hyaluronic acid. Okay, so what we could do is that to decide the thickness, we have placed a spacer of 20 micrometer, another 20 micrometer, so we can get that particular thickness. We made an entire ring of hyaluronic acid, and then we cut it down with the help of the borer, what we use it in our microbiology practical. And that ring was then being sandwiched between the 2 placebo layers. Okay, so we got this kind of a view, as you can see it onto my slide. And this we have also shown it into the research paper what we have published. Okay, this is in open access public domain, this entire research article being published. You can see hyaluronic leaden ring implant into the hydrogel contact lenses. So through the center, the patient would have that particular lesion who is suffering from the dry eye syndrome. Okay, so you can see how it was being sandwiched into between the 2 glass slides. Okay, we have tried to estimate the therapeutic dose considering that the market preparation available of hyaluronic acid eye drop is 0.1%. It is being advised by the ophthalmologist to have 4 times a day. So 1 drop, that is 4 drops will be there, 100 microliter, 100 microgram of hyaluronic acid to be administered with 0.1% strength. Now we assume that there is a 1% bioavailability being there. So 1 microgram of hyaluronic acid is required per day. Okay. Now considering 50% bioavailability, we need 2 microgram of hyaluronic acid for 1 day. We consider that even from ophthalmic lens, therapeutic lens, we will get 50% bioavailability. So we can get 2 microgram of hyaluronic acid 1 day. Out of 2 microgram, 1 microgram will be therapeutically delivered in a day. So 2 microgram hyaluronic acid for 1 day, that is 24 hours. So per hour, I would require 83 nanogram per hour of drug release to be made. So with this objective, with this desirability, we have tried to prepare a lens, and then we have started its characterization. Uska sterilization kiya, how much drug was leached out after sterilization was being studied. In vitro release study was there, how the ion got diffused out was being studied. So 2 major responses that we have studied after preparing lenses as per this particular design matrix. Okay, this particular design matrix, batch 1 and batch 2. We went into the laboratory, we prepared batch 1, batch 3, batch 6, and so on. We characterized it with percentage of a drug leached out after sterilization as one of the response Y1, how much time it took to release the 50% of drug in hours, how much time it taken, and how much ion it got diffused. Okay, that also we studied. So these 3 responses has its direct relation with my objective. Higher the ion diffusivity, higher will be the comfort. If you put on the lens and there is no ion permeability, there is no oxygen permeability, you will immediately remove the lens from your eyes because it is causing a lot of discomfort and irritation. So for me, I want higher ion diffusivity. I want maximum sustained release. So to release 50% of a drug, I should be getting more number of hours. The duration should be high. Minimum amount of a drug should leach out after I do a sterilization via moist heat method of sterilization, that is autoclaving. Okay, now let me show you a screen. Can I take you onto the design expert screen? Just hold on. I just want to stop sharing my screen. Hello, are you able to see the screen of design expert user
Yeah.
interface?
Yes, sir.
Now, are you able to see the screen? Fine.
Yes.
Okay. So this is how all the factors and response were being entered into the software. Okay, we have factor 1, EGDMA, thickness, first response leaching, second response ion permeability, and the third response time required to release 50% of the drug. Okay, you can just double click it and all those being random allotment. So you go into the laboratory, we have prepared a lens. For example, I'm talking about the second number of the batch where I have used cross-linking agent 1%. Thickness of the lens was kept as 40 micrometer, 40. Okay, the lens was prepared, it was characterized. When I characterized, I found that 11% of the drug leached out because of sterilization. I found that 5 milli equivalent of sodium ions were able to permeate of the lens, and I found that it took 90 hours to release 50% of hyaluronic acid from my lens, and so on. So all these 9 batches were being prepared and characterized, and those values were being kept over here. Okay, this is the design what we have used it. The entire summary of it. It shows you we are going to analyze it via quadratic model. Okay, and you have both the factors being studied at what different levels. It shows you the descriptive statistics for the response as well. what is the standard deviation, what is the mean, what is the range, like leaching varied from 7.92% to 13.74% among these 9 batches and so on. Now over here, under the analysis tab, we see that the leaching would be analyzed. We start, for example, if your data are not normally be distributed, this user interface will decide, will give you a pop-up that your data is not normal and you do its transformation. So to make our data normal, because data should be normally be distributed, then only you can go for ANOVA or other hypothesis testing, which is an assumption. So it suggests you to convert those data into either square root or natural log or base to 10 log or inverse square root and so on. But as of now, we find that the data were properly, normally distributed. The cubic model has been allied with the quadratic model. It has suggested us with the quadratic model, and then we go for the model. Now we see over here different tabs. Okay, so it has included the main effect of cross-linking agent, main effect of thickness of the lens, interaction between those 2 factors, as well as the curvature effect, that is of cross-linking agent as well as of the thickness of the lens. Now it does the ANOVA analysis of the variance, whereby we found that the entire model developed for leaching was found to be very much significant. Okay, we see all of those values are less than 0.05. Will not go into much detail about the interpretation of everything. When we say that p value is less than 0.05, we reject the null hypothesis, we accept the alternative hypothesis, which surely means that the probability, the possibility of getting null hypothesis correct is less than 5%. So we reject the null hypothesis. What is null hypothesis? Cross-linking agent does not have any effect on leaching of drug. Thickness of the lens does not have any effect onto the leaching of the drug. Okay, that is what we something call it as a null hypothesis. Now, the possibility of getting this null hypothesis true is less than 5%. So we reject null hypothesis and we have accepted the alternative hypothesis. We get the coefficient table value from here. You can see 12.31, minus 1.41, minus 1.01. So over here in interpretation, I'll again take back you to the presentation. All this data I have incorporated into my PowerPoint presentation as well. But this is just an hands-on with which how we can know what are various user interface being there. These diagnostic tools have to be verified to check whether our model is adequate, whether the assumptions of hypothesis testing have been satisfied or not. Okay, so we see a normal plot of residuals whereby all the points of residual should lie onto the line of residual, or at least it should be into the S shape. With the run residual versus predicted, all the points should be between both the red lines. Okay, and which we find it. It should not give any suggestions for transformation. So box plot is giving no recommendation. So all tools are satisfying the criteria of normally distributed data. Now what we see over here is the model graph, that is contour line. Reddy sir, are you able to visualize?
Yes, sir.
Yes, fine. Now these are the response lines. Okay, when you see onto the entire composition on this line is 12. So if I take, for example, I have kept my cursor over here, the composition of my lens would be 1.13% my cross-linking agent EGDMA, and thickness of lens has been kept to 57 micrometer. So when I go into my laboratory and prepare the lens using these input variables of cross-linking agent and thickness, I will get leaching of the drug after sterilization to 12%. If I take this particular point, okay, and I say 0.82% of cross-linking agent and thickness as 40 micrometer, again my drug leaching would always be a 12%. So on this entire line, whatever is the composition of my x-axis and y-axis, that is cross-linking agent and thickness, I am going to get the response of 12% leaching after sterilization. So this is how the interpretation goes on. From this particular graph, now how much you want, maximum or minimum? Can someone tell me in my chat box how much leaching we get? I'll surely address the queries, as Rakesh sir has asked me, is there any role of initiator in in situ polymerization? Hello. How much leaching I would want? Leaching of drug after sterilization, minimum or maximum? I would require minimum leaching of the drug after sterilization. So which is my desired area? It would be somewhere here. I hope you are able to notice the cursor where I am moving. Okay, less than 11 or less than 10%. So this is my region of desirability. This entire region is of my region of operability. Now, if I go into the interaction, what do we see over here? Both the factors are showing, excuse me, both the factors are showing parallel lines to each other. So there is no interaction being noticed between thickness and the amount of cross-linking on leaching of the drug. We even will notice over here from the p-value of AB, you can see p-value of AB is more than 0.05. Okay, so please do not play an important role in deciding the interpretation of A and B. It can just be an additive because there have been some plus sign into the coefficient of AB. Okay, going back again to the model graph where we have clicked on to the interaction. So when both these lines are showing parallel to each other, it shows that there is no interaction between both factors onto our response. If these were non-parallel, if these were intersecting with each other, then we can conclude that there is an interaction between A and B. Interaction is lack of additivity. So both of them together will produce something more than the synergism. Okay, something more than the additive, what we call it as synergism, or something less than the both of them could be additive, so that can be as an antagonistic in nature as well. Now we have something again, there are a curvature, so there is a linear relationship between it. Now this is a three-dimensional graph, okay, and it's two-dimensional, you can see at the below point. So this entire surface is a response surface of leaching. Same way for ion permeability, it can be also analyzed. I have already kept analyzed considering the limit given to me. Okay, so these are the contour lines. Is there an interaction? Yes, there is a slight interaction between the factors because the lines seem to be not so parallel on ion permeability. As well as on sustained release, let us see. It is showing just a linear model, so you will see the contour lines are very much parallel to each other. And as far as interaction, there is no interaction, both the lines are parallel to each other. Okay, we will come back again to this particular screen with optimization. So okay, so I'll be trying to wind it up into next 15 minutes and so on. Are you able to see now full slideshow of the PowerPoint? Ready, sir?
Yes, sir.
Which screen are you able to see now?
PowerPoint, design expert screen, sir.
Design expert screen. Okay.
Yeah.
How about now?
No PowerPoint.
Now PowerPoint. Okay, thank you, sir. Okay, so this was the data analysis for the leaching. You can see the polynomial equation onto my slide. So which says that x1, x2, x1, x2 have their own regression coefficient. Okay, x1 square is the curvature coefficient, x2 square is the curvature coefficient. Now from the p-value, we could find that not all the terms are being significant. So only significant terms have been included into the next equation. We call it as a reduced model equation. Now when I increase my cross-linking agent by 1 unit, that is my factor x1, my leaching will be reduced by 1.41 units. Because the coefficient sign is negative, so it does have a negative impact onto my response. when I increase the thickness of my lens, that is thickness of my lens is x2 variable by 1 unit, my leaching would be reduced by 1 unit. So that is something, the beauty in which we are trying to develop a mathematical relationship between x1 and y and x2 and y as well via this particular equation. Now there is a non-linearity into my thickness. Okay, so thickness increase करने से ड्रग पहले डिक्रीज, ड्रग लीचिंग डिक्रीज हो रहा है, वापस थिकनेस इंक्रीज करने से भी ड्रग लीचिंग इंक्रीज हो सकता है. So that is what we could see it into our contour lines as well, when it was shown with the curves. Okay, so these are coefficient values and so on. Now something, a column of predicted you see over here. Now in this particular equation, what you see it onto my slide, when I substitute, for example, what is the composition of batch 1? Okay, now batch 1 composition is something where EGDMA is 0.5% and thickness of my lens is 40 micrometer. So that is both are -1, -1. When I went into the laboratory, I got leaching of the drug 12.89. But when I substitute these values into these equations, x1 and x2 as -1 and -1, I get the answer as 12.81. So this is the predicted response from my model, from my equation. Now the difference between my predicted value and the actual value or the observed value, which I get it from my experiment, is something we call it as a percentage error, is something we call it as a residuals. Okay, same way you take the composition of batch 2, you see their values, you substitute into the equation. I got the answer 11.51, but actual was 11.70. So the difference was -3 something percentage error it is. Okay, it was -3.06 and so on. So this is how the residuals are being calculated. Will not go into the technical description why it was observed, but again, just for the sake of understanding, if I say with increasing thickness of the ring, the percentage leaching of hyaluronic acid from the lens decreased due to increasing path length of the hyaluronic acid to permit through the hydrogel matrix. The interaction effects were not significant. I have shown you onto the design matrix software user interface, so the effect can be considered as a negative as well. This is how we have presented this data, where we got analyzed using this software into our paper, all being combined, and even the same has been seen. Then we did the analysis characterization of our second response, ion diffusivity. This is our in-house developed methodology. Okay, we took it into a glass rod. A lens was tied at one end. Into it, 1 molar sodium chloride solution was being filled. 1 molar sodium chloride solution was being permitted across the lens into a donor compartment, and which was periodically analyzed via conductivity meter. Okay, we got such response. You can see Y2 being written. When we substitute its value into the equation, what we get it from the analysis, these were the answers and the percentage error. Okay, so this model was also entirely significant being studied. So both ion diffusivity and the T50 percentage were significantly affected by the thickness of the lenses in comparison to the cross-linking agent. Okay, so you can see the screenshots being taken from the user interface, which we have already explained it. How these lines are to be seen. The analysis of the quadratic model, what we have seen over there, you can see the entire model being significant. The R square is quite high. Now R square interpretation, R square is 0.9815. So 98% of the variations, whatever you observe in the value of leaching over here, is because of the two factors that I have selected. Okay, so higher is the R square, higher will be the predictivity, and lesser or lower would be the residuals, or lower would be the errors of the entire response. Okay, so we got very good R square value 0.98 into our response 1. These are all diagnostic tools. Then response 2, the time required to release 50% of the drug, it showed a linear relationship. So you do not see those curved lines onto this contour plot graph. Okay. So this is how the interpretation goes on for other responses as well, even for ion diffusivity as well. Now, based upon it, I am going to have do an optimization to this particular product development. I want my leaching after sterilization less than 10%. Hello.
Excuse me, sir.
Yes, sir. Yes, ma'am.
Last 5 minutes.
Okay, fine. We had come to the optimum point of our product development. So, just allow me to share that particular screen. Are you able to see the design expert user interface, madam?
Yes, sir. It's visible.
It's visible. So I have kept my leaching to a minimize. Okay, ion permeability I want it to maximize, and T50% I want to maximize. Okay, so I will input over here what is my goal of the different responses into the user interface, and then I will look out for the solutions. Okay, it will give me the desirability point of view. Okay, you can see over here it has given me 10 different solutions. So I go into my lab, I take 1.5% of cross-linking agent, 47 micrometer thickness. I will get leaching of 10%. I will get ion permeability of 3 milliequivalent, and 127 hours will be required to release 50% of hyaluronic acid. So on, you will get, for example, you will get 4-number solution. You can see how these ramps are moving. When you go into the graphical solution, we will find that this particular yellow area is something my area of desirability. So in this yellow shaded area, all my goals will be achieved. What are my goals? Minimizing the leaching, maximizing the ion permeability, and maximum for 50% of release. So you keep a flag over here with the right click. We will get that you use 1.45% of cross-linking agent, 71 micrometer is the thickness. And these are the probable predictions what software is giving. So you go into the laboratory and you are trying to reach to your optimum point. So entire gray area is my desired region of operability. I have reached to my sweet spot to develop my therapeutic lenses, which would have an adequate optical property, an adequate physical property, and adequate sustained release property as well. Okay, so I'll immediately share my PowerPoint presentation. Are you able to see, madam, PowerPoint presentation now? I have changed my screen.
Yeah.
Hello?
Yes, sir. Yes, sir.
Yeah. So this is what I have kept over here on my PowerPoint presentation for you all people. With this, again, with the optimum patch, we did in vivo study in these different ways. Okay, efficacy study as well as kinetic study, dynamic and kinetic study could do it. So we concluded that the hydrogel contact lenses can circumvent the critical changes in optical and physical piece. So this is how we tried to even validate the entire, not go into much of its detail, whereby even we have done in vitro and in vivo correlation study also. So thank you very much, sir. I would welcome any of the queries as I have been asked to stop down with the time limit. Okay, so thank you very much, sir, for giving me an opportunity to disseminate knowledge what we have tried to generate by applying design of experiment at our workplace, our MPharm and PhD students. So I'm very much sure that this is a very important computational and statistical tool which helps us to minimize our efforts and get maximum information. There are a few questions. I think if there is a time enough, I would be happy to answer those questions. Okay, so once again, I am thankful to the principal madam as well as both the ready for giving me an opportunity to interact with you all. via this STTP and there whatever we have with us. Thank you very much, sir.
Thank you,
Welcome, sir.
Ketan sir, for enhancing our understanding pertaining to QBD and enlightening us by your commendable talk, sir. Thank you once again for your support in making this event success. So I wish you keep on spreading the light of knowledge in the future also. Thank you. So, any queries? So that
There is one query that is there any role of initiator in situ
Yes, there is a
polymerization?
role of photoinitiator, and this will only begin the in situ polymerization. And without that role of photoinitiator, the polymerization by exposing to UV light will not begin, and we have controlled it, the photoinitiator amount concentration. Okay. Then also there is another question. Can
Yes,
we
sir.
explain
That's
how
from my
to?
my
Yeah.
side only. I got the answer. During your
I hope.
discussion.
During
Thank
the
you, sir. Thank you.
discussion. So I request participant to, if you can switch on the camera and we can have a kind of a photo with all of us, or if organizers have been taking, then I would be happy to.
Sure, sir. Sure, sir.
I request all the delegates to kindly switch on your videos.
Thank you so much, everyone. Thank you. Thank you, sir.
Welcome,
Thank
sir.
you.
Do stay, stay
Yeah.
safe and do take care of yourself. Thank you very much.
As a token of appreciation, so certificate of appreciation for your excellent lecture. So please accept the certificate, sir, through virtual mode. Hello. Am I
Yeah.
audible?
Yes. Thank you very much, sir, for the appreciation certificate, and it was pleasure as well as honor for me to deliver a lecture in STTP from a very esteemed organization which is accredited by both NBA and NAC. So do not find much more pharmacy institutions across the nations which has been accredited by both the eminent agencies like NBA and NAC. So says that it is a quality institution and have been so much responsible, and therefore they are organizing such STTP for all of us. So thank you, Principal Sir, Madam, both the sir, for giving me an opportunity to interact with the participants through your medium of STTP. Thank you very much. Take care.
Thank you once again, sir. Now I take the opportunity to request Mr. M. Madhu, sir, Associate Professor and HOD of Pharmaceutical Analysis, Annamacharya College of Pharmacy, to introduce the next speaker, Dr. Kalyan Kumar Sethi, sir. Over to you, Madhu, sir.
Thank you, madam. Am I audible to you?
Yeah, you are
Yes.
audible. Yeah. Good morning, Kalyan, sir.
Good morning to one all. I am Madhu.
Kalyan, how are you? Madhu, carry on.
Can you proceed, Madhu?
Good morning to one all. I am Madhu, Associate Professor, Department of Pharmaceutical Analysis. It's a great pleasure for me to introduce today's our speaker, Dr. Kalyan Kumar Sethi, Assistant Professor, Department of Medicinal Chemistry, NIPER, Guwahati, who is going to talk to us about computational tools and techniques for the drug design, discovery, and development. So it is a topic in which we should be deeply interested because the efficiency of drug discovery and designing process can be increased by effective strategies given by computational methods. Our speaker, although having spent almost his entire research career on this field, he is an eminent researcher who has had deep knowledge in the field of pharmaceutical science for over 12 years. He completed his doctoral studies from Birla Institute of Technology, Ranchi, in the field of pharmaceutical science, with a special emphasis in drug design, discovery, and development. He was honored with different fellowships and research grants like Rajiv Gandhi National Fellowship in 2014 from UGC, Institution Fellowship from BIT Ranchi, AICT Fellowship from Government of India. For his service in research development activities in the field of chemistry, and has guided 7 research students of different motives of research in the field of pharmacy. He is a life member in professional bodies like IPGA and Pharmaceutical Society, BIT Ranchi, and editor in JGTPS and EC Pharmacology and Toxicology, along with a professional reviewer of many eminent elsewhere journals. 23 articles of his research work has been published in different international journals. Sir has 2 patents in the field of chemistry. Presently, his research interests include natural product chemistry with a view in bioanalytical studies. With these few words, I welcome Dr. Kalyan Kumar Sethi, sir, to address the gathering. Thank you.
Yeah, thank you, Dr. Madhu. It is a nice introduction. Yeah,
Thank you.
so very good morning, one and all, and Subhadayam. So, Honorable Dr. D. Sonalata Garu, Principal, Annamacharya College of Pharmacy, and my dear colleagues and the teachers. So, thank you very much for giving me this opportunity to spend some quality time with you in this knowledge sharing moment. So, we should not say it is a very, in a different way, we should not take it, and it's just a knowledge sharing between me and you and me, like that. Okay. So just and the special thanks to AICT for promoting such kind of events. It is just like a Guru Sishya Parampara. Okay. So we all are teachers here. So it is a great moment that we all teachers are sitting here and we are sharing our knowledge from one by one, and you can say it is a Guru Sishya Parampara. So in this occasion, I would like to do Guru Vandana to all my teachers and my the teachers sitting over here. So Guru Brahma, Guru Vishnu, Guru Deva Maheshwara, Guru Sakshat Param Brahma Tasmai Sri Guru Namah. So Guru is the creator, is a Brahma. Okay, so Guru is a preserver. Preserver means is a Vishnu, means Palana Karta, you can say. So Guru Deva is a destroyer. You can say it Mahadeva. Okay? And Guru is a absolute Lord himself. And salutation to all Sri Guru present over here. Okay? So in this talk, the slogan I mostly prefer that Vidya Anedi Anderiki, Mariyu Anderiki Vidya Haku Antundi. Okay, Shiksha sabhi ke liye hai aur shiksha par sabka adhikar hai. And in English, you can say it, the education is for all and all have the right for the education, which I believe in my heart. So with this, I want to start my presentation. The topic that I have given, I want to share this.
Will make you the co-host so that you can share the PPT.
No, already sir is co-host.
Sir, you are the
You can
co-host.
share,
So
sir.
you can,
Yeah,
you can share
I'm
this.
sharing it. Is my screen is visible?
Yes, sir.
Yes, sir. You can make it full screen, sir.
Yeah, of course. Yeah, I think my screen is visible.
Yeah, fine, sir. Absolutely fine.
Yeah. So our topic. So our topic is computational tools and technique for the drug design and discovery and development. Okay. So before going to the topic, we should know our background, where we are, what we are doing, okay, and how much we are developed in the with respect to the pharmaceuticals, okay, and the pharmaceutical status of pharmaceutical industry. So please can anybody tell that who is the pharmacy of the world? Anybody? don't feel that this is a presentation. I am going to teach, tell you something big things. Don't feel. Just make it very interactive, and I will discuss and we will participate each other. Okay. Can anyone please tell that which country is the pharmacy of the world? Anybody?
India, sir.
Exactly. Thank you. So India is the pharmacy of the world. So why? Because India is the largest provider of generic drugs. Okay. So it is having almost 20% of the share all over the world. So that's why India is known as the pharmacy of the world. So it's the largest provider of generic drugs. One of the biggest supplier of low-cost vaccine globally. So India is supplying the very low-cost vaccine, and throughout the globe it is distributing. So it is having around 20% global export in generic drugs that meet by India only. Okay, so India has contributed significantly to the global healthcare by ensuring high quality, affordable, and accessible medicines around the world. Okay, so the pharmaceutical industry in India is the third largest in the world in terms of volume. Volume means quantity. The quantity of drugs that we are supplying throughout the world is the third largest. Okay, so you have to understand where we are, where is our position, what is the position of India, and what is the status of Indian pharmaceutical industry. Okay, so these are the information you will not find in books. Okay, these are some latest information that I have collected for you. Okay, so that we should know that where we are. Okay, so that's why now the pharmaceutical industry in India is the third largest. Okay, in terms of volume, the quantity of drug we are supplying to the different countries of the world. And 14th by value. Value means that price wise. Say for example, you are purchasing on land. So what is the valuation of that land? Or buying a pen, what is the valuation of that pen? So in that respect, we are in 14th position. Why? Because our cost of the drug is less. If you are, say for example, we are having one discipline tablet, it is 1 rupee in India. And but you'll buy that in US, you will buy in $1. So it is almost how much? It is 75 rupees according to us. For them, it may be $1, but that's why the value is less for India. Okay. So the next point, the pharmaceutical export from India reached more than 190 nations, around the world. Okay, so almost we are supplying throughout the globe. We have not left a single countries where we are not supplying. So including the high regulated markets. High regulated means their rules and laws are very strict. Okay, like USA, West Europe, Japan, Australia, like that. Okay, so these are the countries where their pharmaceutical regulations are very tight. Okay, 1 minute. Yeah, madam, Sapna madam. Hello. मैडम एक्चुअली मैं थोड़ा टॉप में हूँ AICTP टॉप डायरेक्टर सर एक्चुअली मैं ओके आई एम कमिंग मैडम कमिंग मैडम कैन आई टेक 5 to 10 minutes break? Actually, our director, Dr. U.S. Murthy, calling me. Hello. Hello. Hello, Dr. Madhu.
Yeah, sir.
Dr.
Okay.
Sorry,
Okay,
sorry for the interview because director Dr. U.S. Murthy is calling me. I think some urgent work.
Will you continue, sir, after that?
Yes, just give me 10 minutes.
Okay, sir.
Sorry.
So, dear delegates, sorry for the interruption.
So meanwhile,
yeah.
I will launch one poll.
Yeah, okay.
So please be engaged with that.
Small announcement to the delegates that
So so as per the instructions of ASCTE, so one session on the national education policy has been included in this third phase also. So I hope the delegates will take it granted. Thank you. Surya Prakash sir.
Oh, yeah, ma'am. So now I am launching one poll.
Yeah.
Please try to respond. I request all the participants to respond. Now the question is visible on your screen, I hope.
Yes, sir. It is visible.
Yeah, you can participate in this poll.
నెక్స్ట్ మీరు ఇద్దరా వెళ్ళండి వచ్చిన తర్వాత చేయించుకోండి.
A lot of participants, only 6 participated out of 26. So I request all the participants to actively engage.
So I request the delegates to introduce yourself to your fellow colleagues or fellow delegates. So if anybody is interested, so it's your wish whether you can switch on your video or not. So introduce yourself if you are willing.
The poll will be active for 30 more seconds. After that, I will close and end the poll. The participants are requested to interact, or they can share their views. Interested people can introduce yourself to the audience. So these are all the results of the poll. So 36% opted for design expert, 9% opted for Minitab, 18% opted for jump. All the above, 73% were opted. The right choice is all the softwares can be used in the design of experiments. Meanwhile, you can have glimpse over our college.
Hello. Hello.
Hello, sir.
Hello. Yeah, sorry. Okay. So can I continue?
Yeah, yes, sir.
I'm very sorry, extremely sorry. Actually, I want to share with you also. You are a teacher and I am also teacher. So it is some moment we cannot avoid that the senior most person in this institute, Dr. U.S.N. Murthy sir. Okay. Actually, the happy moment is that actually I completed 1 year in Naipur, Guwahati. So I am a very young faculty over here. So my probation is over today. So, so they given me that probation completion certificate and I become a regular faculty over here. So this is my happy moment. I'm extremely sorry for the disturbance also. And I will welcome you all. If anybody want to collaborate with me and work with Naipur Guwahati, you're most welcome. Okay. So anyway, thank you very much. So I want to share my PPT once again.
So try to finish within the time, sir.
Yes,
That's
yes,
request
yes,
from
yes,
our
yes.
side.
No extra time I'll take. I hear valuable time.
Thank you, sir.
Yeah. Is my slide is visible to you?
Yes, sir. You can make it in full screen mode, sir.
Yeah, that I made. Yes. So that we are discussing regarding that what is the status of pharmaceutical industry in India, and that country home having more than 3,000 pharma companies in India, and over 10,500 manufacturing facilities that are available in India. So we are staying in a great nation, and of course we are having more than 3,000 pharma companies. Okay, and the domestic pharmaceutical market turnover reached almost 20.03 billion. It is the data of 2019. So now it is about to cross 22 billion. Okay, and it is around 9.3% growth since from 2018, and growing as penetration of health insurance and pharmacies rise. Okay, so why this growth is happening, especially in India? Why this 10% like that growth is happening? Why? Because of the insurance policy. Like you can say recently, government of India that Ayushman Bharat. Okay, so if you don't have money, then you cannot go for good treatment. Okay, you will not go to hospital. You will try to manage with some medicine soap like that. Okay, so it is not like that. Okay, but if you are having insurance, the government is paying or somebody else is, or you are having like that affordable insurance you are having, then you will go for good hospital, and you will spend some money in some quality health care, or in quality medicine, buying quality medicines. Okay, so these are the factors why this pharmaceutical markets in India is growing. Okay, because another factor is that our population. So our population is so huge. If everybody will get that insurance like this, what is it called, Ayushman Bharat. Okay, so poor people will come out from their financial burden. They'll come out to the hospital and they will spend more money in the healthcare sector. Okay, that's why this is growing rapidly. Okay, so India has more than 2,000 WHO GMP approved pharma plants, and approximately 253 European Directorate of Quality Medicines and approved plants with modern state-of-art technology. Okay, and India is the only country with the highest number of US FDA compliant pharma plants, more than 262, including APIs outside USA. Okay, so now very general one question will be there. even though we are saying, and it is a pharmacy of the world, and we are having so many USFDA complaints, we are in the top. Can anybody tell why it is like this? Because as a number of plants are there, a number of pharmaceutical plants are there, then definitely there will be some mistake in the manufacturing unit. So definitely the complaint will be more. If you very ideally you don't work, then no complaint will come. If you are working really, then complaint will come. Definitely, it is a normal tendency. Okay. So India is the source of more than 60,000 generic brand across 60 therapeutic areas. Okay. And manufacturing more than 500 different active pharmaceutical ingredients. So API industry is ranked third largest in the world, contributing 57% of the APIs to the pre-qualified list of the WHO. Okay. From 2018 to 2019, India pharmaceutical export are worth around $19 billion. Okay, with a growth of 10.72% a year on year. Okay, so it's a huge growth. It is around 20% growth. So India hold 12% of the global manufacturing side, catering to the US market. So US we are sending around 20% of the drug. The cost manufacturing of India approximately 33% lower than that of USA. Okay, so we are really very cheap. Our manpower cost is low, and we are manufacturing very low, less in cost. Okay. Then what are the major segments in pharmaceutical industry in India? That is mostly that API. You can say it is bulk drug plants. Okay, bulk drug means that active pharmaceutical ingredients. Then from the bulk drug, we are manufacturing that formulation. You can say the tablets, capsule, injectable suppositories, syrups, gels, paste, powder, ointments, all of this. Okay, so these are the formulation. This formulation sector is there, API sector is there. Then the contract research manufacturing service. Okay, comes. So now it is India is just a hub for this contract manufacturing service. Even though you will say that Kiran Majumdar, that Biocon. Okay. So Biocon, that you can say that you might be seeing that Biocon is industry, but Biocon is mostly doing this CRO job. Okay, is giving that facility to Syngene and other and earning money. So it's just like CRO, it's working. Okay. So then the biosimilars, it is a hot topic nowadays. Biosimilars. So biosimilars can be referred as the medicine that are generic version of the biological product. When any biological products that are already in market that expiring, that patent is expiring, then any company that preparing that medicine is called the biosimilar. Okay. So if you are comparing that various segments, the API and CRO, formulation, biosimilars, you can see that API the largest segment, and then the second largest number in the ANDS. ANDS means an abbreviated new drug applications. So that we are in the second largest number. We are filing that abbreviated new drug application. Okay. Then the world leader in drug manufacturing file, sorry, drug master file application with US. Okay, United States of America. Okay. Next is the contract research manufacturing. The fragmented market, more than 1,000 players, and CRAMS industry reaching more than $19 billion in 2019, as per the report. Okay. Next, the formulation. We know that we are the third largest, and we are the largest exporter of the formulation in the terms of volume. Okay, and that we can say it is third largest. Okay. Then the domestic market size used dollar is 11.2 billion. So double, we can expect a double-digit growth over the 5 years. Okay. Then next is a biosimilar. I already told it is a very hot topic. Okay, biosimilar like adalimumab. Okay, so it is a generic. Then some brandeds are there. That's called Humira. Okay. Then other biosimilars after expiring this patent, what is the biosimilar is coming? You can say it is adalimumab. Okay, and other brand, other name are there. These are called the biosimilars. So adalimumab is a biological drug. When it is expiring the patent, the biosimilar is coming. Biosimilar medicines are coming. So don't confuse with that. What is biosimilars? Okay. Next, what are the sectors and how it is the market size is growing? in India. If you say in 2015 to 2019, in 2015 it is 15.5 billion US dollar, and in 2016 16.41. So like this is grown, and it is around 22 billion in 2022. Okay, so the market size is almost growing like anything. So pharmaceutical sector is always safe in India, and huge. We may be thinking that so many pharma colleges are there like that, and no, everybody is observed. You will see after 1 or 2, maybe one first year or exactly after completion of the B Pharm or M Pharm, maybe people are roaming, but it is not like that. Everybody is getting the job. So the pharmaceutical is just a boom, and it is silent boom. Okay, and it is growing like anything. So the future in pharmacy is great in India. Maybe salary will be a little bit less. That is okay, but you are getting the job. That is fortunate enough. Okay, so the top composition sector. If you are seeing that sector, this is very important slides. Why I am saying that you have to understand the sector, which sector you want to work. If you are designing any research, and if, say for example, you are designing any research for your B Pharm student or M Pharm student or PhD student, then you have to understand which sector is the hot sector. You can say that anti-infective is the very hot and very demanding sector. You can say that it is 2.58 billion US dollar, then the cardiovascular, then the gastrointestinal, then anti-diabetic, then vitamins, minerals, then respiratory diseases, then pain and analgesic, then derma means skin disease, okay, then neuro, CNS, then coming the gynecological problems. So these are the sectors that is really demanding in market. You see, so in seeing this, you can design your project according to this. So that's why I am telling it is very important slide. So these are the segments you have to work, and you can design your projects and you can work according. So it will be in demand. Okay, next. Now you can see that global discovery, that outsourcing market set to grow across the globe, and this trend in India, which predict to be that 1 minute, that compound annual growth, that is called CAGR of around 16%. If we are seeing that CAGR of India, how it is growing in global drug discovery outsourcing market. Global drug discovery outsourcing market means we are having the CRO, or we are having the facilities, and we will outsource the discovery things. Okay, and that outsourcing market in India is growing 16%, whereas the China CAGR is 13%. So we are going to overtake China by 2026. Okay, you can see the predicted graph. Then we are going to a topmost in the world in case of global drug discovery outsourcing market. Okay, that's why we are having the bright future for the pharmaceutical students. I think 2 people are waiting in the room. Next, then now we can see that pharmaceutical cluster. So what are the varieties? If you are seeing that the pharmaceutical cluster in India, that you can say the captive R&D unit, R&D units, established bulk cluster, formulation cluster, then emerging bulk drug cluster, emerging formulation cluster. You can see that starting from the north in the Baddi, then in Haridwar, Delhi NCR, Sikkim, Ahmedabad, Ankleshwar, Bapi. So all these Visakhapatnam, then this Hyderabad, the biggest, you can see that Hyderabad itself is consuming the 4 drugs. Okay, so many companies are there. In Visakhapatnam is a hubby where I was in Gitam University. I can see that the pharma park is there. Okay, so then in Chennai, Pondicherry, then Bangalore, Mysore. So many, you can see that half of the India is full of this pharmaceutical. Ignore about the small state, although they are having, but you can see, but these are the states where this pharmaceutical cluster is filled. Okay, so next, that incentive that the government is paying, that you can see that the projects, very big projects that government already initiated, that you can say it is around 13,760 crore government is paying for the 4 major scheme. Okay, one is the bulk drug park, then production linked incentive, then 4 medical device park, 3 bulk drug park, and their production linked incentive. If you can see that for the incentive outlets for bulk drug is 9,940 crores. Okay, and for the bulk drug, 3 bulk drug park is coming. The one maybe in one is I think Maharashtra, one is coming to Hyderabad, I think. So like that, 3 or 4 states taking this bulk drug park, very big unit, with all facilities. Okay, so in the bulk drug segment, we are having the very bright, because we are coming for the self-reliance, means we are going for this Make in India concept. Okay, so in that, that's why this government is pushing money for this, because we are very much dependent on China and others, some of the other countries for this bulk drug API. Okay, that's why government is pushing this money for the establishment of 3 bulk drug park. Okay, so with having every facilities. Okay, and that is for 100 crores, 1,100 crores for each bulk drug park. Similarly, the medical device park. Nowadays, this is also new area where you can work, and it is a medical device, that area. Okay, so this is also a very nice and it's upcoming research area where you can work. Okay, this is the bulk drug scheme that the government of India pushing. Okay. The next. Yeah. Then you can see that global innovation index. So we are slowly reaching to our topic. So global innovation index. So you can see that where we are. So I think in 2014 that this government is continuously working and giving a lot of effort to increase the facility, and all the respect the government is working. So you can see that India just this is I structured in some government website that you can see the India up 5 slots in global innovation index. We are happy? No, we should not be happy that we just 5 slots up. Okay, so in 2015 our rank was 81, 2016 66, then 2017 it is around 60, then 18 it 57, 2019 we are in 52. Now it's somewhat, but government is working very aggressively on this. Okay, so if you are seeing that global innovation, that Switzerland and Sweden, US, Netherlands, UK, Singapore, Israel, all these 10 Western countries are there in the top, and we are at 52. So what do you think? You want to work on innovation or not? So you have to work on quality education, and you are the teacher of India, and you have to work. We have to work, not you only. I have to work. I have to work. Okay. So we have to work like anything for the, because we are the builders, we are the constructor, we are the, like anything, whatever you say, we are the Guru, Brahma and Vishnu. Okay, so we have to make our nation a proud nation. We have to take the level so high. Okay, so this is what we have to work together, and we have to take our nation really high. Okay. Next. Then if you are comparing simply working on a research and like, but you have to you have to safeguard your research or your innovation in terms of patent. Okay, you have to file the patent, not in publication. Okay, don't spend time. You can do the publication, but thing is that you have to file the patent first. If your molecules, or if your product, or if your what you can say process, whatever is, if you are feeling that is newly innovative. Now today itself, government has announced that 80% slash in the patent filing. Today's news, very recent. Okay, today's news, government has announced 80% slash for the patent filing. Okay, so you can go blindly and work on patent. Okay, file the patent. You can see that graph I am showing you. You can see where we are. See, this is China is where is China, and it is 1,000. If you are seeing that the global distribution patent filing in one sector like I sector, okay, so you can see where is China. China is very smart and doing like anything, and that accordingly you have to be very smart and you have to work, because simply some molecules you are, even though it is very new, even small institute, they are working very nicely. They are innovation power is also a international standard, but thing is that they don't have the motivation. Okay, they don't know what they have done. They might have done very good job. Okay, that thing, if you are publishing, that pharmaceutical companies very cunningly observing what these people are doing, and after publishing they will take your scheme. So don't go for publication immediately. First you protect your innovation. Okay, that is in terms of patent. So you can see how China is nicely doing. So you have to work. Okay, you have to work hard for this patent. And the government today's news is slashed around 80% of the fees in patent filing that you can search. Okay. Then now it is our responsibility that we have to work on the drug and the innovation. Okay. So slowly we will go for the innovation. How this so innovation is not simply that chemistry, it is a work of pharmaceutical chemistry people. It is the combination of all the branches. You can say that if it is starting from that molecular modeling scientist, then it is slowly coming to the chemistry, then it is coming to the biology people like pharmacology and toxicology, then the pharmaceutical formulation, then clinical pharmacy. So all the branches are all together. So it is not that drug discovery is only confined to one people or one set of branches. It is not like that. Okay. So all the branches are involved. Okay. So it is all together. We have to join hand each other and we have to work. If you are having something innovative, you come out and you work and you come with your innovative ideas and you work sincerely, and you definitely will get your desired things. Okay. So if you are seeing that steps, what are the steps? If you are like, first of all, if we are going to the drug discovery, we are still not in topic. We are outside the topic. Okay. So if you are drug discovery, if you are thinking that first of all, what you are doing, you are identifying any disease. If you want to work on cancer, or if you want to work on diabetes or something else like that, then first of all, you are finding out the disease. Then what is the target? Okay. Any cell you want to target, any receptor you want to target, or you want to target the nucleus or any like that. Okay. Any protein or any enzyme you want to target. So that is your, after identifying the disease, it is the target. So target selection is required. Then with the help of some computational techniques, you have to do all the molecular modeling part. Okay. Then after that, you are finding the hit molecules. Okay. From the hit, you have to generate the lead. Okay, that is called hit to lead generation. Okay, from that, then the synthetic people having the work to synthesize that hypothetical molecules to bring that hypothetical molecule to the real ground. Okay, and they'll work. Okay, after getting that hypothetical molecule in a real in your hand, then what is that thing? Then they have to characterize. Okay, they have to find out what is the purity of that compound, what is that really that compound has formed or not, like that. Okay, so analysis people will work. Okay, in that you have to find out the purity. Purity is a must. I have found in India it is very, very lacking. Whenever I'm taking any interview in India, okay, especially that students joining the PhD in NIPER, everybody, even most of the teachers, they don't know what is the role of the purity. Okay, that you have to understand. Why that HPLC purity is important to all the discovery people are not. Why? Because it is all required. Because see, if your drug is only 90% pure, okay, so 10% impurity is there. So when you are preparing any dose, so what is including the 10% impurity? So your dose calculation is wrong. So you have to exclude the 10%. and you have to take the calculation from the 90%. So 90% is a pure drug. Again, another challenge. Your molecule is cis or trans. Okay. Racemic mixture. If your drug is a racemic mixture, then again it is a problem. Okay. Racemic mixture means one will be active, one will be inactive. You got my point? Again, your drug is only 50% pure. You got my point? So you have to find out whether your drug is a racemic mixture or not. If a racemic mixture, which one is active? You have to separate both the components. Okay. So that racemic mixture means it is your drug is 50% pure. Okay. So that is why it is very, very essential. This is what are the points I'm telling. It is you must note down and you have to implement in your research work. Okay. So most of the teachers, they are doing this mistake. I found that's why particularly I'm raising this point to all of you, and I'm telling you. Okay. So otherwise you will be caught. Okay. All your innovation, all your research work will just go to the dustbin. Okay. Nobody is going to take it. Okay. Then just that I want to just highlight what is high throughput screening. So it is high throughput screening. It is just a robotic techniques that generally it is not possible everywhere. So it is very high techniques. Rapidly means within a day or two, they can within a day means they can screen about 1 lakh compound in a day. So you can find out the robust method. Okay. So in that they will easily find out that heat identification means the COVID. Okay. And the COVID there is no solution. So immediately what they will do, all the molecules, all the pharmaceutical immediately they will screen. Okay. So that is a robot. Within a 1 or 2 days they will find out. They within a 1 day they can screen 1 lakh molecules. That is called high throughput screening. So then immediately they will find out the heat. Okay, this is the molecules. Okay, it may work. It may work. I'm not saying it will work. It may work. Then immediately what they will do from heat to they will generate some of the modification they will do. Then the work of synthetic people will come and they will synthesize. They will evaluate. They will help of get the computational techniques, QSR, all these things, and they will immediately find out the drug candidates. Okay. Then how you will confirm the heat. Okay, heat means that some molecules it will be biologically active. Okay, out of all the molecules, some will be active. Okay, that active molecule you are taking. So how will you, that confirm that you have to confirm that okay, this is the heat. How will you confirm? You have to confirm by various methods. Okay, you have to take the dose response score. Okay, whether it is working or not. You have to take confirmatory testing. The data should be reproducible, not today you worked and it is giving better result. Tomorrow when you are working, there is no result. It should not be like that. So the data should be reproducible. Okay. Then only you can say that heat molecule is confirmed. Otherwise not. Okay. Orthogonal testing means the confirmed heat are assayed using the different assay, which is usually closer to the target physiological condition or using a different technology. So with the target physiology are there, you are very close to that, then that is called the orthogonal testing. You have to confirm that. You have to assay with that receptor or that binding using various methods. Okay, then that is called the orthogonal testing. Then secondary screening you have to do with the confirmed heats are tested in the functional cellular assays to determine the efficacy. Okay. Next, other methods like synthetic tractability. Okay, then that biophysical testing, then heat. After that, what you'll do? You'll do the heat ranking. You have to rank. Okay, because so many compounds you have screened. Okay, then you have to rank which one from best to worst. Okay, then you want to accept evaluate. Okay, then you are evaluating that. Okay. Then heat expansion. Okay, in that ideal properties of heat compounds. So here a lot of information there. It is not only restricted to chemist people. It is also required for that pharmacology and pharmaceutics people. Okay, so that high affinity towards the target. Okay, whenever you are doing that's high throughput screening, So you should, that molecule should have that affinity towards the target. Target may be a protein, enzyme, or that nucleus, nucleic acid, whatever it may be. Okay, it should have the affinity, and it should be less than 1 micromolar. Okay, then selectivity versus the other targets. This is very important. Selectivity versus the other target means you have to see the selectivity. Selectivity, it should be particularly go and bind to that particular receptor. Not, it should not affect the other part. Okay. So for example, you are designing any molecules that is for the anti-cancer. Okay. So particularly that drug should go and bind to that particular cancer cell, and it will damage that. Not it will go and other place, and it will damage the kidney, it will damage your eye, it will damage your lungs. It should not be like that. That's why selectivity is very, very important. Okay. If there is no selectivity, then your drug is not going to work. Okay. Then it will be very difficult. Okay. Next is significant efficacy in a cellular assay. Okay. When you are doing the cell-based assays, that should be significantly active. Okay. The drug likeliness means this should be that you can say it is lipophilicity, O by H, W by O, all these things. Okay, pharmaceutical people, okay, pharmaceutics people, that you can understand. Okay, drug likeliness. Okay. So this is very, very important that it should be, because if it is not at all soluble, then how you will give that drug? How you will push that drug to your body? If it is not at all soluble, it will go and roam inside your body. It will sometimes enter to your heart, sometimes go to enter to your lungs. Then it will do a lot of problem. Okay. It should be solubilized, it should be digestible, or it may be, it should undergo metabolism. Then only that thing. Otherwise it will go and bind particularly, and it will be for whole life, it will damage. Okay, so it should not be like that. Okay, then low to moderate binding to that human serum albumin. Okay, it should be moderately bound. Okay, otherwise it will go and particularly bind to that albumin protein, and whole life it will be like that. Then it will be very difficult. Okay, it should, after some time, it should come out. Okay, and it should eliminate through either in stool or in urine or other way. Okay, otherwise it will be very difficult. So low interference with this cytochrome P450 enzymes. Okay, it will be very important enzyme. It should not be a low interference with that. Okay, otherwise it will destroy other pathways. Okay, then low cytotoxicity, very common. Okay, metabolic stability, it should be stable. Otherwise, simply you are taking within your stomach, it will digest. So, so it will not work. It will go to your blood. Okay, or it will not reach to a target. Simply in a system, digestive system itself, it will digest. Okay, so it is not required. So high cellular membrane permeability should be permeable, and either it may be either it is lipophilic or hydrophilic, but it should be permeable. Okay. Then high water solubility, okay, that is very important. Okay, chemical stability, synthetic tractability, and penetrability. Okay, so these are the points. It should be the ideal characteristic of a heat compound. So similarly, that we have covered up to this, that this preclinical. Now, after this high throughput screening, all these things, now we are going. Okay, after all this result you are getting, then you have to go for scale up. What do you mean scale up? Means, say for example, in lab scale we have prepared, then you have to go for a large scale. Okay, that is called scale up. You have to improve the quantity of the drug, and you have to get the more quantity of drug for various study. Next, after scale up, the work of this formulation people, pharmaceutics people, they will work, and then they have to go for file for a IND. Okay, okay, investigation new drug. Then you have to go for the human clinical trials. It may take some time. After, if it is successfully going, then you have to file NDA, a new drug approval of the FDA approval, so that it will, after that you will get your product. Okay, so this is the roughly some steps involved. Now we will go for a case study. Okay, how we are generally, because we are in academician, and or some may be working in industry, but with our limited facility, how we will work. Okay, and how we can work together, or with collaboration, or within the institute. Okay, they have to get some successful products in our hand. This is the case studies, that is drug design, discovery, and development. That's particularly exclusively, I'm giving one example, that is the human carbonic anhydrase inhibitors. Okay. So first of all, how step by step we have to understand. It is just an example. Okay. But you can work in other area. You can work in other area, but you have to understand the how you are going to design a discovery project. Okay. Okay. First of all, you have to understand separate the carbonic anhydrase. You have to understand the what is carbonic anhydrase. Okay. So carbonic anhydrase, what is it? It is a metal enzyme that is present in prokaryote, eukaryote. It is ubiquitously present everywhere. It is present in the body, and it is carrying out lot of physiological and pathological processes. What are those? It is involved in the respiration, transport of CO2 and bicarbonate between tissue and lungs, pH and CO2 homeostasis, electrolyte secretion, and in the various tissues and organ, gluconeogenesis, lipogenesis, ureagenesis, tumorigenicity, growth and violation of various pathogens, and regulation of CNS activity. Okay, so various pathways, these enzymes are involved. Okay, then okay, now we understood. Okay, this is the enzyme, this is the function. Now what next? What next means you have to find out what is carbonic anhydrase, then what is its classification. So this carbonic anhydrase, it is around 5 categories. Okay, alpha, beta, gamma, delta, epsilon. Okay, and especially in human, it is find the alpha carbonic anhydrase. So alpha carbonic anhydrase not only in human, in vertebrates and even in bacteria, algae, and cytoplasm. In cytoplasm of the green plant is available. But in human, that is called human carbonic anhydrase. That is of 16 types of isoenzymes are present. You can see 16 isoenzymes are there. Then very tough, no? If you are targeting one, it may bind other, it may inhibit other. Very tough. So I am giving you a very tough example. Okay. So how drug discovery for this particular carbonic anhydrase, it is really tough job, because inside your body 16 types are available. Okay. Say for carbonic anhydrase 1, 2, so many are there. Some are present in cytosol, some are present in membrane mount, some are found in mitochondria, some are in secreted saliva and milk. When you drink cold drink, yeah, immediately some burp is coming. Why? What is that? Because of this carbonic anhydrase. Okay. Carbonic anhydrase immediately doing some chemical reaction. Okay. And this is the role of carbonic anhydrase. Okay. So some are transmembrane, some are cytosolic. Okay. Some are extracellular, and they're everywhere distributed in the cells and tissue. Okay. Say for example, the carbonic anhydrase 1, it is found in the erythrocyte, GI tract. If you are considering the carbonic anhydrase 2, it is found in erythrocyte, eye, GI tract, bone, osteoblast. So many places it is available. Okay. Similarly, other like carbonic anhydrase 9, it is found in tumor and GI mucosa. Like this, so many distribution are there. So throughout the body, this kind of enzymes is available. So it is really difficult to get that is called drug specificity. So drug specificity to carbonic anhydrase 1 or 2 is very tough. Okay. If you are seeing that the sequence alignment homology, okay. Any idea about the sequence alignment homology? Anybody? If you have a little idea, then I can otherwise. Sequence alignment homology means, say for example, that protein. Okay, say for example, this is carbonic anhydrase. This carbonic anhydrase having so many amino acids. It's a protein. No? The protein having the amino acid. So when you are seeing the sequence in one particular enzyme, if you are isolating one enzyme only. Okay, so many enzymes here. I have shown you 4 enzymes: carbonic anhydrase 1, 2, 9, and 12. Okay, so this 4, if you are seeing that how much very close association is there. Okay, very close means they are very similar structure is there. Okay, very few are different, and but many cases it is very similar. Okay, so it is very difficult to go for a drug discovery in carbonic anhydrase. So we have used these tools that is called UCSF Chimera. So this is the software. It is freely available in the site. So you can use it for your sequence alignment homology and to get different structure that it is for your project work, okay, research project work. So it is freely available. You can download it and you can learn. Okay, if you want to learn, you can further contact me. Okay, because in this small time I cannot explain each and everything. Okay, so just I'm telling how this sequence alignment. If you're seeing the sequence alignment, how close they are, or each protein they are very close to each other. If you're seeing the same four structure in three-dimensional way, you can see that how they are very nicely they're packed. Okay, very less place you'll find that it is somewhat little bit different. Okay, you will find it very nice. You cannot find this is four isoenzyme is all together is there. You cannot find, very difficult. Okay, so four are there. Okay, and I see for example 1, 2, 3, 4. One place you can see that it is having some difference, but other place it is fully merged. Okay, so this is how that other term it is called specificity. Okay, next is the disease model. Okay, if you are seeing the disease model, how this carbonic anhydrase is related to any disease. Okay, so for example, what I would say, because this enzyme is packed in your body fully, it is available in every organ in your body. Okay, now you may ask, it is a very useful enzyme, why this enzyme is causing the disease? You may ask that it may be a very general question. Okay, am I right or wrong? So the problem will start. Say for example, you are having one boyfriend. Okay, handsome boyfriend is there, or you are having one beautiful girlfriend. The girlfriend will start talking to somebody else. Then the problem will start. Okay, that is called activation. Okay, means that the problem is like this, when this enzyme, when it is overexpressed, that is a particular terminology we are using, the problem will start after the overexpression. Okay, you are normal, you are very nicely cooperating with your body, enzyme is very nicely cooperating with your body, then it's very well and good. Now overexpression, when overexpression will start, then the problem will start from that point. Okay, so overexpression of any of the isoenzyme will cause particularly the disease. So what are the diseases related to carbonic anhydrase? There are many. Okay, so I can say you that you can say it obesity, cancer, infection, edema, epilepsy, osteoporosis. So these are the very key diseases responsible with the carbonic anhydrase. It is, if you are going for the activation of this enzyme, okay, overexpression of this enzyme. When the expression is below that what is causing it? It will cause the Alzheimer's disease. Okay, for that carbonic anhydrase activation is required. Okay, but for this kind of disease like obesity, anti-cancer, cancer, infection, edema, epilepsy, that is called carbonic anhydrase inhibitor. Now you decide you want to work on inhibitor or you want to work on activator. Okay, so you have to decide. Now, say for example, you are choosing the cancer. Okay, you want to work on very favorite topic to all. Okay, and you want to work on cancer. Now you have to understand the mechanism again. How this cancer is happening because of this carbonic anhydrase. How this carbonic anhydrase is involved in the cancer. You have to understand the mechanism. So this is the courtesy to the Nature publication. So I'm sharing with you. This is one of my collaborator from Italy. So this is the publication from him that published in Nature. Okay, so I want to describe this mechanism. This is that there will be two conditions in your body. One is hypoxia, another is normoxia. Okay, hypoxia means there is a shortage of oxygen. I think very last time is with me. So in a hypoxia condition, hello.
Yes, sir.
Yeah, so can you extend a little bit time or I have to finish in time?
Because afternoon session is by 2 o'clock only, sir.
Okay. So I'm just in a little speed I'm telling.
Okay,
So
sir.
in the hypoxia condition, okay. So but it is very beautiful topic. Okay, in hypoxia condition, okay. Directly I'm telling the hypoxia condition. This hypoxia inducing factor, it will not going to stabilize. But in normoxia condition, it is going to break down. Okay, this hypoxia inducing factor. Okay, so that's why you want to tell that you do pranayam. I'm just linking this science to your daily life. Very, very important. Okay. Hypoxia means there is lack of oxygen. That's why people are saying you do meditation, you do yoga, because when you do meditation or some pranayam, especially pranayam. Pranayam means pranam. Okay. Your life means in that pranam you are doing the vyam, means exercise. Okay. Pranayam. So why it is so important in your life? You can see this mechanism. Okay. So you need sufficient oxygen in your body. When you have sufficient oxygen, the what is it called? Dioxygen, okay, O2. When the dioxygen level will reduce, immediately this hypoxia inducing factor will what is that? Propyl for hydroxylase. This enzyme will particularly stabilize and it will not work. Okay, and it will this bond-epoidal indole protein will not go and bind and it will not spoil like this. It will go and accumulating and slowly it will pass to the cytoplasm to the nucleus. Okay, nucleus, his brother is there. What is that? This is hypoxia inducing factor alpha, and there his brother is there, hypoxia inducing factor beta. Okay, the hypoxia inducing factor beta, it will go and it will generate some this transcription factor and it will give that carbonic anhydrase 9, birth of this carbonic anhydrase 9, which is responsible for the pH regulation, and it will go for the tumorigenesis. Okay, so the hidden, you may be thinking I'm not taking any cigarette, I'm not taking that what is the tobacco, but still I'm getting cancer. Why? This is the hidden enemy there inside your body. Okay, so even though you will not take anything, but you have to face this problem. Because this carbonic anhydrase 9 is a hidden enemy that is present in your body. If you give that factor, if you induce that factor, if you induce the hypoxia, definitely you are going to get the cancer. Okay. Another term is the happy hypoxia. Okay, it might be a very new term. Okay. Happy hypoxia means you are young that you are unable to understand what is hypoxia. If you are so old, then you can easily understand. Okay. So with the age you are age is increasing. Okay, I'm getting this pain, that pain, this disease, that disease. Okay, like that. So like this, so this that enemy is inside your body. Even though you are not taking any tobacco or even you are not taking anything, cigarette, nothing. Even though you are going to face the cancer because of such kind. This is a very good mechanism, and you have to practice pranayam. Okay, so why pranayam is important? I'm relating. Next, this carbonic anhydrase 9, it is responsible for so many cancer. It is there, gliomas, mesotheliomas, papillary carcinoma for the bladder, urinary cervix, nasopharyngeal, head and neck cancer, breast cancer, esophagus cancer, lungs cancer, brain cancer, vulva cancer, kidney tumors. So many factors, so many. I have listed so many. You can understand how many cancer it is responsible. Okay, so then the target. Okay, so now your target is carbonic anhydrase. You have to understand it is having one hydrophobic and hydrophilic like that. Then you have to design your carbonic anhydrase inhibitor. So carbonic anhydrase inhibitor, particularly so many are the natural products like phenols, polyphenols, phenolic acids, coumarins. Okay, sulfamates and sulfamates. So say for example, you are working particularly in this compound. Definitely collaborate with me. Okay, I'll help you to do this project. Okay, and we'll do. Okay, I have some mold and we can do carbonic anhydrase. Okay, next these are some example I've shown the mechanism. Okay, how it is binding. So then the heat identification, the heat, how you are finding the heat. Already I have discussed some ligand-based drug designing methods are there, structure-based drug design methods are there. Okay, so like this, if you were going for the ligand-based drug designing, okay, then you have to select one database and you have to proceed further and you do all this job. Okay, so some of the publication we have got, it is in informal healthcare, that is Journal of Engineering, that is important 5.0. Like this, some means work that we have done and it is published. Then the pharmacophore based modeling means you have to see that which pharmacophore is desirable for your molecules, okay, to get the particular activity higher. Okay, so these are some methods, and you can find out like this. So these are some softwares that you have to use. So these are software, I mean, computer means you can say computation tool that is helpful for this to design such kind of model, okay, to get the heat molecules. Okay, after getting the heat molecule, you have to design so many molecules and you have to synthesize that. Okay, then how will you synthesize? Again, you have to go for the, that is called structure-based drug design. You have to take the receptor, you have to dock it, and you have to finally get the higher score, and the higher score than the desired, that already established or co-crystallized ligand. Then you have to choose that for the synthesis. Then after that, say for example, I have summarized all the molecular modeling part, that you can go for the COMPA model, you can COMSIA model, that is pharmacophore-based drug design, then the structure-based drug designing, then you are getting finally the heat molecules. Okay, from the heat you are generating the lead molecule. Lead molecule you are synthesizing. This is the heat molecule. After doing all this pharmacological, using all the pharmacological tools, and you are getting the heat molecules. Okay, then you are getting the docking score. So getting the best docking score compound, you are synthesizing. Okay, then you can see that interaction, how drug and receptor is interacting. That is very, very important to the drug molecules. Okay, then you are synthesizing all the molecules. After synthesis, you are analyzing all the analysis people are involved in this. Okay, then after analysis, you are going for the pharmacology. Okay, so when you are comparing with, say for example, you are taking on a standard molecule, that is called astazolamide. Okay, so after comparing the astazolamide, say for 250, your molecule is using 143, some molecule 185, very close. So these two are active for the carbonic energy too. Okay, so for this is 12, and your compound is not active, so it will not work for carbonic energy 2. If it is 2.5, okay, so in 2.5 you can, but it is not active that much. Okay, but in some carbonic energy 9, you are seeing it is 25. So most of the molecules are active for the CN9. Okay, like this for this. So like this, you can choose for the next step. That is, then you can go for the structure activity relationship. Okay, then after evaluating the structure activity relation, very important this, because you have to know that which structure you work which side. Okay, then you have to go for filing of patent. Then you have to file that, and because you have to protect your innovation. Okay, so we have also filed some patent. Then we have published. After filing, you can publish that. Okay, then next you can see these are some of the products. Then you can go for this pharmacological study. Okay, then you can go for the clinical trials. So you can go for the clinical trials, and you can file some of the there's so many phases are there that everybody knows. Okay, and you are if you are lucky enough that your molecule is working, then you will go for the FDA approval for the phase 4. Okay, so some of the success stories in the molecular modeling, you can show that dorzolamide, okay, imitinib and cimetidine, then Jomambivir, all these drugs, you can see that is a success story of molecular modeling that you can see. Okay, so with this, I want to conclude. So I'm in a hurry, I have done this. Okay, thank you very much. If you want to collaborate with us in the future, then you can contact me. Yeah, thank you very much. If anybody having any doubts, you can ask.
Yes. Thank you, sir. Today we have an excellent opportunity to listen to your presentation, Kalyan, sir.
Yes.
Thank you. You have presented a very well, very clear explanation. Thank you once again. Pradeep, sir, could you share the certificate?
Yeah, madam.
Yeah. So chat box don't have any there is no queries, sir.
Okay.
Very good person. So please accept this certificate on behalf of Annamacharya College of Pharmacy as a token of appreciation.
Okay, thank you very much.
Thank you, sir.
I am equally sorry for the in between some disturbance, but unavoidable. I'm sorry for, and I want to say sorry for all the participants.
It's okay, sir.
Sir, congratulations for your completing your probation period.
Okay, thank you very much. Yeah, next time anything anybody want to speak or you want to learn something, you are most welcome. Because this is a very short time and we cannot explain each and everything. If you want to work seriously, you please contact me. Okay.
Sure, sir. Thank you for the cooperation.
Okay. Thank you, madam.
So dear excellent informative sessions. The morning session is concluded. So afternoon session is scheduled at 2 o'clock. The 2 sessions will be more beneficial. Thank you. Thank you once again. Have a nice day.